Good day, Professor One. Welcome to our database product demo. Our team members include me, Eddie, Edgar,
Hello.
and Larry.
Hello.
Today, we'll be presenting our tutoring platform database and demonstrating its core features. The system we built is designed to manage a complete online tutoring platform. It handles student and tutor registrations, lesson scheduling, payments, messages, reviews, and disputes. Let me begin by explaining the entity relationship diagram. So right here, we have our ER diagram. We have entities which include student, tutor, lesson, payment, message, admin, dispute, refund, review, homework, and subject. In each entity, we have multiple attributes. So for example, in the student attribute, in the student entity, we have attributes including the student ID, student name, student email, and student phone number. So for each entity, we have these types of attributes. And then in each entity, we also have relationships. So for example, for the student, we have a relationship that the student pays for lesson, the student gives reviews for lesson, the student participates in a lesson and can submit homework, the student sends a message, and the student can be involved in disputes. So for each entity, we have these types of relationships, and for these relationships, we also have cardinalities, also known as multiplicities. So for example, when a student pays for a payment, the one student can make multiple payments, but each payment is associated with one student. Another example is that the payment pays for the lesson, so each payment can be associated with multiple lessons, but a lesson can have 0 or 1 associated payment. I can go on and on. So another example is that the student sends a message, so one student can send many messages. The tutor sends a message, so one tutor can send many messages also. The lessons assigned to students, and a lesson can be assigned to a student and taught by a tutor. So a lesson must be assigned to one student and taught by one tutor. For the lesson has homework relationship, a lesson can have multiple homeworks entries. So one lesson can have multiple homework entries. For the review given by a student, one student can give multiple reviews. For the tutor teaching a subject, one tutor can teach multiple subjects. And for the subject taught in a lesson, one subject can be associated with multiple lessons. So we can move on to the business logic and workflow of this project. So the student registration and lesson booking, a student registers and browses available tutors and subjects. Then from what they like, they select a lesson and make a payment using one of our supported payment methods. So they may choose the tutor they like. If they like the tutor, they book a lesson and they pay for the lesson. Also, we have a lesson assignment. We have a communication, homework and review, and dispute and refund. So this is all a part of our business logic and the workflow. So the key integrity constraints is that one-to-one and one-to-many constraints are clearly enforced, ensuring that data duplication and ambiguity are avoided, and mandatory participation. So for example, in certain entities, like a lesson implies that both tutor and student must exist for a lesson to be valid, and optional participation in entities like homework and review means lessons can exist without them, but they may be represented. Every relationship is clearly mapped using foreign keys, ensuring referential integrity across the platform, and I'll move it on to Edgar.
All right. Thanks, Eddie. And now I'll walk through our DBMS. Yeah, so we're using DB Fiddle, which is pretty much MySQL, but it's online. And we just found it easier to collaborate here. So here we have the schema. I mean, we don't have to go over everything, but we just create the tables with some example data. And then we can walk through some live queries right now. Yeah, so we're just doing select star from student, and we have an error.
Give me a second, please.
Yeah.
Okay, there you go.
There we go. Yeah, so in here we can see the tables. Yeah, so we just populated with using insert, and we retrieve it, as you saw, using select star. So, we have, for example, let's say you have admin Alice Smith or admin ID 1 for Alice Smith. Here's some example emails. And same thing for the next table. That it was just using select star, so we're just showing all of the data. So yeah, here's the student table, subject, tutor, lesson, homework. I mean, pretty much all the entities in our ER diagram. And we have review, refund, dispute. Yeah, so it was just to verify all the data is being populated and structured correctly. From here, let's go through some aggregate queries. Thank you. And then, so these are going to be using SQL functions like count, average, sum. All right. So yeah, so like select count as admins from admin just to get, total number of admins. And yeah, here it is. Total admins, total students. And then we have, that's the average hourly rate for the tutors. Yeah, here's a list of the lessons based on status. So we have like completed, schedule, ongoing. Next query is going to be different homeworks based on submission status. So there's 2 graded, 1 pending, 1 submitted. Here we can see this is the total payment. It's just basically some amount at total payments. Messages, total rating. That is for the reviews attribute. And then refund by rating or by status, I mean, and dispute status. All right, and then from there, Larry's going to be introducing some more queries.
Hello, so now I'm going to be showing some join queries that demonstrate the direct relationships that were presented in our ER diagram by Eddie. So I'm going to run using the same schema SQL commands we use to create our tables and populate the different tables. I'm going to put a couple of query SQLs here that show each direct relationship that is found in our ER diagram right here. So here are the commands, and when I run them, for each relationship, the first query I ran was for the relationship between the students and their payment method, payments and their payment method and payment status. The next query was the relationship between the tutor and the amount they received, as described here on our diagram. And the next query was a query to demonstrate how each student is being matched with a tutor, and how they communicate, like the message content and the message time. And the next query here will be to demonstrate each tutor name and the subjects they might be tutoring on. So like here, the result that was outputted here was Mr. Thompson teaching mathematics, Miss Carter teaching physics. And the next query number 5, was a query to demonstrate the relationship between the tutor and whether or not they have completed a lesson. So a relationship between the tutor and the lesson. The lessons vary by group and one-on-one lessons, and as you can see here in the result, Mr. Thompson had a group lesson and it's completed. Miss Carter has a one-on-one lesson and it's scheduled. So that's just a query to demonstrate the relationship between each tutor and the lesson and the lesson status. So query 6 here demonstrates the relationship between each lessons and homework submissions. Query 7 also demonstrates a relationship between the students and the reviews table. So whether or not they're given a 5-star review and the review content or the text as well. Query 8 demonstrates the relationship between the refund and the dispute. So it will give a brief description of the reason for the dispute and the dispute status, whether or not, because not all disputes are going to be accepted. So as you can see here in the dispute status, some are open, some are closed, some are under review, and some have been resolved. And whether or not a dispute is settled will determine whether or not they are going to be refunded, as seen in the refund status. Query 9 demonstrates the relationship between the admin and the dispute, because the admin is the one in charge of handling each dispute. So they are able to see the issue description, and from that they are able to determine whether or not to refund the student. So those were the different queries we ran to demonstrate each relationship that is found over here in our ER diagram. I'm going to move it over to Eddie to give some conclusion remarks on our project. Eddie?
Thank you, Larry. Our team and explained the ER diagram. All data from each table using basic select queries. We ran an aggregate query for each table to analyze data. Demonstrated join queries for every directly connected relationship. We validated our system, and lastly, we validated our system using real use cases. This entire demo, we will upload the video to YouTube, included in our site, in our submission.
Thank you.